So the primary competition we handle is USACO. USACO stands for the USA Computing Olympiad, equivalent to the, thank you, USABO and USAMO, et cetera, the camp systems. Our goal is to get you as high as possible. There are a variety of reasons people do it. One, it's kind of fun. Two, it's like better than biology that you don't have to memorize the textbook to compete. Three, if you guys are interested in college applications, making camp is basically guaranteed admissions to MIT, so there's that. Variety of reasons, but basically we're going to be covering that. So the way USACO is split up, firstly, just like some bureaucratic stuff, is there's 4 levels. Bronze, actually I don't think it's right. Bronze, silver, gold, and platinum. Yeah. So bronze is basically like introduction to programming. Like here's a problem, write code to solve it. It doesn't really matter how effective it works. It's just you have to be able to solve it.
It's a nice group back there.
So silver is more of like beginning to understand some efficiencies. The problems are slightly more tricky. You have to understand data structures. So you have to begin to use more complicated things and understand how these different techniques can help you solve the problems in efficient times. And that's something we'll go into slightly later in the lecture, but basically how you solve it within the time complexity. Gold is subsequently even more advanced. We're trying to go into more complex techniques, segment trees, more efficient sorting and searching algorithms, etc. And then platinum is just like raw problem solving ability. Like here you have all the fundamentals. Here's some very difficult problems that require innovative thinking. How do you solve it? So for the purpose of this group, our goal is basically to get you guys to gold or platinum by the end of the year. It's fairly straightforward, mostly because like bronze almost everyone passes within their first contest. And a decent of you will get to gold as well. Mostly because the first levels are like, do you actually know computer science? Which means, can you write code?
Wait, just as a show of hands, just to get an idea, how many of you have taken, like how many of you are freshmen? No one?
Wait, how many of you guys have taken foundations or starting with it? All right, how many of you guys are in APCS or have taken APCS? Okay, so almost, yeah, everyone.
How many guys of you were post APCS?
Okay.
All right, sounds good.
Decent amount. Okay, so the way basically the contest works is you have 3 problems. So each problem is, I don't really know.
And it also depends on the contest. Sometimes there's 4, sometimes there's 3.
Yeah, and so there's 4 contests throughout the year. The first 3 are December, January, February, and then there's the US Open. So each contest is a chance to promote to a higher tier. So the way it works is if you get all the problems right, or if you get like enough of them right that you pass some threshold, you get promoted to the next tier. Ideally, you want to get to the highest tier possible. So the better you do, the like higher your chances of rewards are. Right?
And this threshold is set by USACO. So like they see how participants do, and based on that, like if it was a very hard contest for everyone, they'd say like everyone. So these contests are out of 1,000, right? So you have these 3 problems, right? Each one of them is worth 333 points. And basically, they see how other kids have done, and based on that, you're able to like rise ranks.
So the way it works is like Ashley mentioned, there's 3 problems, right? So each problem is typically some different topic within each section. It might cover like different data structures or different approaches. But basically, there's 3 different questions. Within each question, there's 10 different test cases. So this means the way the problem works is here they give you a write-up, right? Like here's the situation, here's the input data, here's the output data. You have to match some pattern. And then they give you a sample case. So you run it on the sample case, you might do some of your own testing to make sure it works, right? So like let's say I'm like printing out the sum of the Fibonacci sequence, right? So like n factorial, or I'm just printing out n factorial, right? So they give me n as my input and I print out n factorial. So what happens is they do the test case and they give me the test case. So it works, nice. Now I run it through and I submit it to the grader. So their grader runs it through 10 test cases that you don't know. So these 10 different test cases are completely unknown to you, and it tells you how your algorithm performs against each test case. So for every single test case you solve, you get that many points. So the way it works is you have basically a box for each one, and you have 2 seconds to solve each test case. So if you get enough time...
Or it depends on the language.
Yeah.
So like if you use C++, you have a second. And if you use Java or Python, you have 2 seconds.
So basically, if you get it right, you get a check mark. If you get it wrong, you get an X mark. If you have a time error, you get a T. And if you have
a memory limit exceeded error, which would probably only happen at higher levels.
If your code breaks, right? Like if you have a runtime error, you get a star. So basically, you want to get as many check marks as possible, and these 3 are all basically bad. They're just like giving you more information to what you need to improve. So in most cases, you're going to get check marks for most of them. Maybe there's a couple of edge cases, right? Like for example, let's say you have a question that says, find the greatest product from this list of numbers, right? So if you have n numbers and you want to find the largest value such that T1 times T2 equals the max, and both T1 and T2 are in this set of n numbers, right? So in most cases, it's pretty straightforward. I just loop through it, I get the 2 biggest numbers and multiply them together. But some of the harder test cases, like questions 9 or 10, might be something like -100, -99 to 30. So in this case, if I just loop through and take the 2 biggest numbers, I'll get 6. If I multiply the 2 negative numbers together, I get like 9,900, right? So it's just like figuring out these interesting cases where you might not necessarily think about it when writing your code. And so that's how each test case gets progressively harder. The test cases towards the end also test the bounds of your algorithm. And this is something we'll talk about slightly later in the lecture, but the idea is basically you have to solve it in some time complexity. So you have 2 seconds to solve it. And the harder problems have more and more data. So the first question might have like 4 values, right? Just for finding the product. The harder ones might have like 100,000 and so on. And it keeps getting larger and larger. So it means you have to get more and more efficient. In most cases, I would say if you solve the problem, you get 4. So there's 4 test cases which are completely independent of time. No matter how bad your algorithm is, you probably will get all 4 in the first one. Everything beyond that starts pushing the time complexities. So you have to be able to solve it in an efficient way. Essentially, your goal throughout the 3 hours that you take the contest, or 4 if it's the US Open, is to get as many of these test cases as possible. In general, each one's worth about 30 points.
Wait, can you resubmit?
Yeah, you can resubmit.
So that's one of the things we'll talk about towards the end of the lecture, but there's a lot of interesting tricks you can do. Actually, like we call it milking the grader, right? So you don't know what the test cases are, but you can make like reasonable assumptions based on that. You can kind of cheat the system. But basically, you can submit it as many times as you want. So if I get it wrong, I can be like, oh look, you know, what if I didn't think about this? I said about it, and I fixed that case. I just resubmit it, and I'll get it right.
So do you take it at home?
Yeah, you take it.
So the way it works is it's hosted over a weekend from Friday to Monday, and within that you have 4 hours to take the contest. So at any point within those 4 days, you can click begin, and it starts the 4-hour timer.
And actually, if you get a perfect score on any one of the divisions within that same weekend, let's say like I'm pretty sure like since most of you have taken CS, right, you'd be able to like pass the bronze division with relative ease. So like you'd be able to take the bronze division if you get a perfect score, then you'd be able to move up to the silver division during that same weekend, right? So so therefore it's like theoretically possible to go from like bronze to platinum, which we have seen.
So like for example, I think Daniel last year didn't know like had never done USACO, and he made platinum in his first contest. So theoretically, like it's possible if you're good enough. But basically, yeah, there's enough flexibility. I personally always tend to do it on Saturdays, just because school's on Friday and Monday, and Sunday like, watching football or something. But it's really flexible. It's up to you guys. So that's basically the general format. Most competitive programming competitions will follow something similar. They might adjust the time bounds and number of questions.
Right. One thing that USACO does, and it's like pretty unique, is file I/O. So like in code forces or like other programming competitions, they typically use standard I/O, where you just read from. If you're using Java, this would be like system.in, or if you're using C++, it'd just be like C in and C out. But yeah, they just use standard I/O. And USACO, sometimes if you use Java, you'd be able to do a couple tricks to make it like scanners. Like sometimes are known to be like inefficient in the contest programming community. So you could use other tricks and stuff to.
Like for example, right, my second contest, it was a gold contest. I didn't end up solving one of the problems, and it turned out I figured it out after. It took me 5 seconds to load in the data and less than half a second to solve the problem. So because I was using scanners, right? So stuff like that is stuff we'll cover. We'll literally like give you guys best practices for taking it and loading out data. And that's just like something you have to handle. The first contest you guys will probably be doing is Virginia Tech. So Virginia Tech hosts their ICPC competition, which is a remote competition. So typically TJ sends like 20 teams, something like that. So you just stay after one Saturday, and we all go into one of the rooms. Like everyone gets free pizza and stuff. And basically, there's like 5 hours long. You get a team of 3, and you do as many as you can. And that's typically most people's like first experience because USACO starts somewhat later. But basically, our goal is to prepare you guys. So we'll cover the relevant material you need. We'll help you guys do like case studies, like prepare for it. Typically, we'll also review contests after. So the first part we're going to talk about is computational complexity. This is like how algorithms can solve a problem in a specific amount of time.
Yeah, so basically in computer science in general, like, we use computational complexity as sort of like a measure to determine like how fast an algorithm is, right? And computational complexity can like then like branch out into 2 types of different complexities, which would be time complexity and space complexity. Time complexity would be how much time it would take for your algorithm to run. And space complexity would be how much memory your algorithm takes up. And basically, like when I say how much memory, you could think of it as like the amount of numbers you're storing in like a specific data structure, or like just like the sheer amount of space you're taking up on the computer by running your program. And yeah, because most of you have taken like APCS, this should be a pretty familiar concept. Basically, the idea of big O notation. And the one thing that is pretty important.
Wait, just for a quick show of hands, how many of you guys do know what big O is? How many of you guys don't know what big O is? Alright, so just like
yeah, okay. So like big O notation is basically like it's basically a way to like measure the computational complexity of something. So like let's say you have like print or something like that, right? This would be like big O complexity 1 on like because like for any input size n, right? It would only print out this like one thing, and it wouldn't need any sort of processing to do that, right? And so let's say you were to like, let's say I was given like n numbers, right? And I had to find like the max out of that, right? So then I could write a for loop, right? And I'd be able to traverse the n numbers, right? And then I'd be able to like set up a max and be able to find the maximum that way. But for this, I'd have to traverse all n of the numbers, right? So like because of that, the time complexity for this would be O of n, whereas the time complexity for this would be like O of 1. That's sort of like the basic gist, like a 2-sentence nutshell on like.
So if you have like a for loop within a for loop, then it becomes O of n squared.
Yeah.
Because you're looking through the whole list for every value list. The 2 other ones are like logarithmic. So that's basically at every point you disregard half the data set to binary search. So if I have a list of sorted numbers and I'm looking for 3, I start in the middle and I say, okay, is this number greater than or less than 3? So if it's like 10, then I know 3 is on the left side. I can disregard half of it. The other one's exponential, but like we don't really care about that because if you're writing exponential code, you're doing something else. So,
I mean, not necessarily, but like in the majority of cases, if you're writing exponential code, there's probably a better way to solve it. And yeah, so one thing that's important to note in contest programs is that so because we have this like big O notation, right? We want a way to like convert that to like seconds, right? Like how many seconds does it take for like my algorithm to run? And like the best way to do this is to like use this good rule of thumb in the contest program community, which is like 10 to the 8th operations per second. So you can see like in section 5, we have a cheat sheet listed out for basically for so usually in problem statements they'll define the input size. Some contests don't, and that's actually like pretty bad practice. But based on this input size, you can sort of gauge what kind of algorithm they're looking for. So like let's say I got something that indicated like a logarithmic time complexity. That'd be leaning towards something that's like binary search or something like that to find the answer. And yeah, so that cheat sheet is there for you. All you'd have to do is just plug in the 10 to the 8th operations and check how long your code is taking to run.
So the bigger part of computer programming, especially algorithmic work, is not necessarily writing the code, because in most cases you can just like look it up and learn it. It's figuring out what strategies you need to match this specific time complexity, right? So it's not necessarily like writing; it's more of like the thinking part. That's a more difficult aspect.
Yeah, and then implementation problems are typically what you'd find in like the bronze level, and this sort of like language like refers to problems where like in the problem statement they define like and they tell you like what to do, and you just have to make sure that you write code. And like the majority of problems in contest programming are not like this. So it's just that like that's like the initial set of problems that they do to get you warmed up and get you acquainted. And yeah, if you guys want to practice, the first resource that I suggest would be the USACO training pages. They have a lot of good introductory material there. They go over some of what we talked about today, and you can always find this lecture on the website. So like the best way to get better at this is to do a bunch of problems, to learn the different concepts. And yeah,
So,
questions?
yeah.
When is USACO?
So it'd be on select weekends throughout the year. I think they've announced it on their website. Have they announced it yet?
I think the dates are up. I can tell you it's December, January, and February, and then one in
March is the
April.
US Open.
Oh, right, yeah. Something like that.
Yeah.
Wait, and there are 3 or 4 problems per contest?
Yeah, 3 or 4 problems.
So it's 3 for everything but US Open. US Open is larger.
Yeah. I think it's still 3 days.
Oh, right.
Yeah. But they give you 5 hours instead of 4 hours on the US Open.
So typically, like they're all contests are the same, unless camp selection. So the way camp selection works is not necessarily a high score.
There are a lot of other factors that go into being selected for camp.
So typically they want to build a team for IOI, which means if you are younger, you have a better chance of making it. Which, like for example, a sophomore has almost double the chance of getting camp than a junior, because they want to. They're either going to say you're good enough that you can make the international competition, it's like top 12, or you're good enough that we think if you come for a year, we can develop you for the later competition. So like, for example, Justin and Daniel both made it sophomore year, and you need a lower score for that, which is easier. Any other
So
questions?
it's not just plain score that goes into camp selection. It's kind of almost like a black box. Sometimes people that you think would make it do not make it, and sometimes people they think should not have also make it. So there's a lot of things that go into account, and I'm pretty sure like the USACO staff is like pretty well trained, because our team usually does pretty well at IOI every year.
In general, though, it's like pretty straightforward. You score high, you get it.
Yeah.
The only major factor they consider is age. So if you're a freshman, you get platinum, you get like 500 on all the contests, you'll probably make it. Versus like if you're a junior, you need basically like 800.
Like near perfect scores on every contest.
Any other questions?
Wait, so your like level can change? Like from, like how does that work? So like let's say you take the first contest, and then like you're bronze, and then the second contest, then you move up to gold. Then like,
So okay, so you can't just jump straight from bronze to gold. I mean, you can, right? But like, you just pass the thresholds, right? And then they put you in the higher threshold.
So you can
Right.
never demote. You can only promote upward.
You can only promote.
Okay.
And then it's just like how well do you score. So like if you don't take a contest or something, there's no punishment. Like you can't go down.
Yeah, go ahead.
Does it reset every year?
No, it does not reset every year. So if you're in platinum this year, you'll be in platinum next year and the year after.
So like I think they've only ever reset it once when they redesigned the system. So previously there were only 3 tiers. And I think
They
R.
didn't even reset that. They just put all the camp people in platinum.
Yeah. But it's like I made platinum sophomore year and I'm still in platinum. Even though I only took like 1 contest last year. Any other questions? No. Okay. So if you guys, how many of you guys were here for the first day? It's the first day contest. Some. Okay. So if you guys had, for those of you guys who weren't here the first day, we had our first day contest. Typically that's like, I think it was 10 problems. Each one's about like 2 to 3 in each level. I think that's like a really good way to figure out
Where you stand.
Yeah.
And what kind of things you would need to work on.
So if you guys are interested in doing that, I think the form you have for the first day contest, which you can find on our website, academics.tjhsst.edu/SCT, has information for signing up. You can just message one of the officers and we'll add you to the code forces group. But that's like honestly the best way of figuring out, here's how well I can do.